27.417 meters.
Okay, not a problem.
Yeah. Okay, sir. And this.
So, how many of you have solved the last problems? What's your name? You're Koti, right?
Yes, sir.
Thank you. మీలాగా యాక్టివ్ అంటే మేము కూడా యాక్టివ్గా ఉంటాం లేకపోతే మేము కూడా డల్ అయిపోతాం. So, how many of you other students have solved the problems which were given in the last class? Are you there?
Yes, sir.
Have you
Yes,
solved the
sir.
problems? Who is this?
Shravanti, sir.
Yeah, what are the answers you got?
First one, 167.42. Second one, 86.602 meters.
What is the chainage of D? What is the distance of D from A?
Distance of
D from A.
100.
Huh?
B from A, sir.
Hmm.
100 meters.
Not B, D. Is asked in the question, what is the chainage of D, right? If chainage of B is 100 meters, find the chainage of D.
186.602.
BD to D, then it will give you what is the equal to 186.602 meters is the chainage of D.
Yes, sir.
Okay, chainage of any point is nothing but what is the distance of that corresponding point from the starting point of your survey line. Please keep that in mind, all of you. Okay, whenever anyone asks you the question, find out the chainage of B or C or D. That means what is the at what distance that corresponding point B or C or D is there with respect to the starting point of the survey line. Okay. So I'm moving to the next topic, which is called compass surveying. So before moving to this compass surveying, just a small introduction. What are the disadvantages of chain surveying? Because the disadvantage of chain surveying has become the source for doing a compass surveying. Though compass surveying also has its own advantages and disadvantages, but it's a bit better than chain surveying. So before proceeding to that, what are the disadvantages of chain surveying? What you have learnt in the previous classes? I want some answers, at least from few students.
We can't measure the angles with chain surveying, sir.
Okay. Any angles?
When we have larger area, we can't use chain surveying.
Accuracy అనేది correct.
Yeah,
Accuracy, there can be a lot of human errors while doing it.
Okay, there will be a lot of human errors. Instead of counting 100 links, you might count only 98 links or 101 links because of a laborious work. Okay, that is one more disadvantage. Another major.
There will be, like, as you said, the measurement, the chain also may increase and decrease its length due to the
Okay.
temperature and uneven grounds.
Yeah, I want one natural error. What you are saying are human
Sir,
errors
obstruction.
and instrument
Sir,
errors.
time taking.
Natural error. Time taking is not natural. It depends on the capability of the person. Natural
Sir,
error. Yeah. What?
obstructions when there are
Yeah.
obstructions.
So when there are any natural obstructions in the form of a grass or in the form of a boulders or in the form of a pond, etc. kind of thing, you can't drag the chain or you can't measure the distance between two given points using a chain or a tape. So in those cases, how to proceed? I don't have any other option. I need to do the survey and give the report to the client. Okay. So in those kind of situations, we generally go for compass surveying because we are measuring the minimum number of distances and also we are going to measure the angles between different sides or different objects in the field, and thereby we are going to determine the other measure the other unmeasured distances. Suppose you are having A, B, C, E, D like that 5 to 6 points in which you
Sir, you're not audible.
సార్ వెళ్ళిపోయారా?
యా వెళ్ళిపోయారు, నెట్వర్క్ ఇష్యూస్ ఉన్నాయి.
మేబీ కాల్ వచ్చింది అనుకుంటా, కాల్ కట్ అయింది కదా.
అవునవును.
Yeah, there was a network error. Am I audible now?
Yes, sir.
Yes, sir.
So there was a network error. So my question is, suppose there are 10 to 12 objects with which I need to do the measurements, and out of this 10 to 12, only 5 to 6 I am able to do the measurement using a chain and a tape. And remaining 5 or 6 are not accessible to me because of obstacles. So if I measure the angles of those obstacles, angles of those unmeasured points, with a combination of angles and the distances measured for the known sides, can I make out what is the distance between the unmeasured objects using trigonometric principles? Yes or no?
Yes, sir.
Yeah, sir.
Okay. So that is the basis of compass surveying. That is, whenever it is not feasible for us to do the chain surveying with the help of a chain or a tape, we are going to measure the minimum number of distances, as well as we are going to take all the possible angles. Okay. And using the combination of these angles and distances, we are going to determine the unknown measurements as well as determine the area enclosed within the given survey. Okay. So that is the basic for compass surveying. But compass surveying has also its own advantage and disadvantage that I'll cover in the last slide. Okay. But let's go into the actual topic. So this is what chain surveying can be used when the area to be surveyed is comparatively small and is fairly flat. But when the area is large, undulated, and crowded with many details, triangulation, which is the principle of chain survey, is not possible. In such an area, the method of traversing is adopted. The principle of chain surveying is triangulation. The principle of compass surveying is traversing. Okay. So what do we mean by traversing? Okay. In traversing, the framework consists of a number of connected lines. The lengths are measured by a chain or a tape, and the directions measured by an angle measuring instruments. In one of the methods, the angle measuring instruments is the compass. So hence in compass surveying, directions of survey lines are determined with a compass and the length of the lines are measured with a tape or a chain. This process is known as compass traversing. So what do you understand from this? From this statement, what you are able to infer?
We measure the boundaries or the area we're using a tape or a chain, and then we take the angles and find the total unknown.
See, are you able to see this figure traversing a red pentagon?
Yes, sir.
Yes, sir.
So compare it with a chain survey. If I want to determine the area using a chain survey, what I'll do? I'll divide this into a triangle from here to here. Again,
Yes,
I'll
sir.
divide this area into a triangle like this. So then I'll measure the distance DE, EA, and AD. Again, I'll measure the distance AB, BD, BC, CD. Okay. So how many measurements I need to do now? 1, 2, 3, 4, 5, 6, 7 measurements I need to do. Do you all accept with it? Using a chain surveying. If you want to determine what is the area of this ABCDE, I need to divide the survey area into this form of set of triangles, and I need to measure all these distances, right? 1, 2, 3, 4, 5, 6, 7 measurements I need to make in the field. Okay, but in compass surveying, what happens? I'm not going to measure these two. I'm going to measure only 1, 2, 3, 4, 5 sides. I'm going to measure linear measurements, and I'm going to take 5 angles here. I'll establish my instrument at A, and I'll find out what is the angle between AB, and I'll establish my instrument at B and find out what is the angle at BC. Okay, what is the angle of ABC? I'll find out. So when I know the distances, the lengths of these distances AB, BC, CD, DE, and the angle ABCDE, using your cosine rules and the cosine rules, or using your trigonometric principles, you can determine what will be the areas, what will be the lengths of intermediate sides. Suppose this side is there. I've measured only 2 distances and angle. Can I measure what? Can I calculate? Not measure. Can I calculate what is the distance of AD from this triangle now? Without measuring AD? There's a difference between measuring and calculating. I'm measuring distance DE and AD and measuring angle E. So with these 3 measurements, can I calculate using my geometric formulas the distance of AD?
Yes, sir.
Similarly, for
Yes,
BD,
sir.
for BD also I can calculate, right? I'll measure the distance in the
Yes,
field BC and CD, and I'll measure the angle C. So using these 3 information, I can calculate what is the distance BD.
Yes,
So that
sir.
is the advantage. This is a simple figure which is having a pentagon, but if you go into a larger survey area where you need to do surveying for 5 to 6 days, etc., kind of thing. So what we are going to do, we are going to move around the boundary of the area which need to be surveyed, and we are going to fix the points A, B, C, D, E along your boundary. Okay, you're measuring only the boundary and the angles between the points on the boundary. So remaining things are calculated using your geometric formulas. So now you compare how much amount of work is there in chain surveying and how much amount of work is there in compass surveying. It is getting reduced, right?
Yes, sir.
A simple example, there are 7 measurements you are going to make. 7 times you need to measure the distances. Okay. If I assume that the distance between A and D is 500 meters, the distance between B and D is again 500 meters, and your chain length is 20 meters. So how many lengths of chain you need to measure? 500 by 20. Now take it as 400. 400 by 20 means 20 times you need to drag your chain in the field for measuring AD and for measuring BD. So 20 plus 20, 40 times you need to drag your chain in the field to measure what is the distance between A and D. Okay? So that is the disadvantage in chain surveying, and which becomes the advantage of compass surveying. So in compass surveying also we are going to do linear measurements with the help of a chain or a tape, but the amount of measurements or the quantum of measurements, linear measurements in compass surveying gets reduced, which the time which got reduced can be used to calculate the measurements, the angles or the distances using your geometric principles. Okay. So the concept of compass surveying or the principle of compass surveying is that traversing. We are going to move around the area to be surveyed, and we are going to fix some points from where you will be measuring the distances as well as the angles. Once these 2 are measured, then it is simply your office work where you will sit in the office, recall all your equations, what is the area of a triangle, what is the sine rule, what is cosine rule, all those you'll recall, and you'll calculate what is the measurements. You'll measure you'll calculate what are the distances. Okay, so that is the principle of compass surveying. This question is definitely a Viva question. What are the principles of surveying? What are the principles of chain surveying? What is the principle of compass surveying? Can any one of you answer now? What is the principles of surveying?
Work from whole to parts.
Work from whole to part, and second one is
Representing one point basing on other
2 different
other
points.
different points.
Yeah. So what is the principle of chain surveying? చెప్పాను కదా.
Triangulation.
Triangulation. What is the principle of compass surveying?
Transversing.
Traversing. So please don't get confused. Most of the students, what they do is, if you ask what is the principle of chain surveying, they'll say working from whole to part and establishing a new point with respect to two different points. So that is not the right answer. The principles of surveying are those, and the principle of chain surveying is triangulation. That is, we are going to divide the area into set of triangles to determine to measure the area. And the principle of compass surveying is traversing. We are going to move around the area to be surveyed and thereby do the measurements. Okay. Please keep these 3 points in mind. Okay. But in what cases we can recommend compass surveying, in what cases we cannot recommend. So the disadvantage of chain surveying will become the advantage of compass. Okay, where it is not possible, where the number of numerous distance measurements, we generally go for compass surveying. But the disadvantage is compass consists of a magnetic needle. So whenever there are magnetic modes in the nearby the compass instrument, or even any material, metallic material, which in some cases it can be your smart watches also. In some cases it can be high tension electric poles. Or even in your ranging rods, when you are carrying your ranging rods nearby the instrument also, there is a possibility that the magnetic needle which is there in the compass will deflect. And there is a possibility of getting errors. So 1 degree change in the compass reading is equivalent to 108 kilometers. It is 108.8, approximately 109 kilometers of linear distance. Okay, so if you do a small mistake in measuring the angle of 1 degree, manaku 1 degree anna chinnagane anpistadi. But if you convert that, as I said in my first class, instead of going from Hyderabad to Vijayawada, you'll go from Hyderabad to Guntur. So you need to be very careful when you are using a compass surveying, and you need to ensure that there are no magnetic items nearby the instrument. Okay, that is the only possibility of making an error in compass reading. Other error is human error. If you are not able to see clearly through the instrument what is the angle, that is a human error which can be rectified. But if at all there are any magnetic items nearby, okay, you cannot control the compass. It will definitely, the magnetic needle available in the compass will definitely deflect and you will be getting the wrong results. So you need to ensure that instrument is in proper condition and there are no magnetic influences nearby the compass survey in order to use that. Okay. So we have 2 types of compasses. One is prismatic compass and a surveyor compass. Okay. So you can see in the picture a prismatic compass on the right hand side. You will be having a circular graduated ring. So this one is the magnetic needle. Okay. So this rotates. On this there will be a needle. So this rotates, and all this on this you will be having the graduations from 0 to 360 degrees. Okay. And each 1 degree will be again divided into 3 parts. That is 20 minutes, 40 minutes, and 60th minute will be by default the 2nd degree. Again 2 degrees 20 minutes, 2 degrees 40 minutes. By default the 3rd division will be the 3 minutes. So like that we will be having 0 to 360 degrees. And you will be having a slit. Okay, this is called as the object vane, and you will be having a fine wire in this object vane, which is used to bisect the given object in the field. So this wire which is available in this slit, which one here, which you are able to see, okay, this some opening is there here, right? In that opening you will be having a fine wire. That wire should coincide the object for which you want to take the angle. Suppose if you are taking a ranging rod as an object in the field, the wire which is available in this opening should fall on the ranging rod when you are seeing it. That is, the wire as well as the ranging rod should be in the same line. Then only we will say that the object is sighted. Okay. Then you have a prism here on the right hand side, which is used to measure the angle. What is the angle? The purpose of a prism in a prismatic compass is the values which are available on this graduated circle are in the reverse form. They are engraved in a reverse form. So if you are using a prism, you will be able to see the values in the correct form. So 90 gani, 60 gani, 30 gani, ఏదైతే values ఉన్నాయో graduated circle ring మీద అవన్నీ మీకు రివర్స్ ఫామ్ లో ప్రింట్ అయి ఉంటాయి ఇన్స్ట్రుమెంట్ లో. సో మీరు ప్రిజమ్ తో చూసినప్పుడు ఏమవుతుందంటే మీకు కరెక్ట్ ఇమేజ్ వస్తుంది. మీరు ప్రిజమ్ లేకుండా చూస్తే ఏంటంటే మీరు ఐడెంటిఫై చేయలేరు వెదర్ ఇట్ ఇస్ 16 or 19 or. So that is the purpose of using a prism in this prismatic compass. Okay? The values are engraved in a reverse fashion on the graduated circle of the compass. That is the reason why we are using a prism, in order to see the values erected or in a correct form. Okay. So this instrument is handy. You can even take it in your hand and you can use the system. You can use the instrument. But whenever you are using this instrument, you need to do 3 operations which are mandatory, which are called as temporary adjustments. Okay. So the three temporary adjustments are centering, leveling, and focusing. You'll be having one more instrument called as a tripod, which you are able to see here, which is having 3 legs. Okay, you need to fix your prismatic compass to this tripod. There will be a hook on the top of the tripod and there will be a hook on the bottom of the prismatic compass. You need to simply tie those two. That is compass or tripod మీద పెట్టి తిప్పేస్తే మీకు ఆ screw fit అవుతుంది. Okay? So the placing of this tripod is also very, very important. You should ensure that the 3 legs of this tripod are distributed uniformly. One side should not be up and other side should not be at the down. So when you establish this tripod, you move all the 3 legs aside and place it on the ground. Move away around 1 feet or 2 feet from the tripod and see whether the tripod is looking flat or not. Whether there is any inclination towards any one side. Whether there is any leg towards upside, whether there is any leg towards the downside. So you need to adjust this tripod legs using your common sense so that it appears to be flat, or it will be flat when you go back and see from a distance. Okay? If you're watching it immediately by standing adjacent to the tripod, you'll never be able to tell whether it is flat or not, whether it is level or not. So you need to move back and check whether from a distance the tripod is parallel to the ground or whether it is flat or level to the ground. So once you fix the tripod, then you need to fix your compass instrument to the tripod. Okay. So once you do these 2 operations, then the first operation what we need to do is called as a centering. So centering is nothing but establishing this compass instrument exactly on the position of the station point in the ground. Suppose I have a point A, B, C, D in the ground. Okay, those are my station points. So what I will do, I'll fix my peg or an arrow at point A in the ground. So after fixing the peg in the ground, which defines my station point A, what I'll do is I'll adjust this tripod along with this instrument in such a way that the bottom point of this tripod will be exactly coinciding with the top of the peg which I've driven in the ground. So to check whether these 2 points are in line or not, what I'll do is I'll take the help of a plumb bob or I'll take the help of a small stone. I'll place it at the bottom of this tripod leg, this black portion which you're able to see. I'll place it at the bottom of this and simply drop the stone gently. If the stone falls exactly on the peg which is driven in the ground, it means that the instrument is perfectly centered over the station point. Why centering is important? As I said, a small variation of 1 degree angle is going to result in a linear measurement of 108 kilometers. So it is mandatory for all of us to ensure that the station point as well as the instrument point are in line. Okay. If at all it is not in line, then you need to adjust this compass instrument along with the tripod by rotating or by moving the tripod legs circumferentially. Okay. You should not move it to the one side or to the other side. You should move only in this direction circumferentially. And you need to ensure that the center of the compass or center of the tripod exactly falls on the peg in the ground. So this is one typical operation which takes a lot of time till you get experience. Okay, but this is very, very important whenever you are doing the works of high quality. For low quality works, not a problem. Okay, it doesn't matter if you are doing a surveying experiment in our lab. It doesn't matter if there is some problem in the centering, because we are only learning how to make the measurements. You're not doing any project to any client, or you're not involving any budget in that. Okay, but if you're using this compass surveying for high-end projects of worth lakhs or crores of rupees, then centering plays a very important role in getting higher accuracy data. Okay, and leveling. Okay, so once you have fixed this and the instrument is centered properly, exactly on the station point in the ground, then you need to move back aside and see whether the compass which is fixed to the tripod leg is level or not, whether there is any inclination towards any one side of the compass, or whether it is looking perfectly horizontal or perfectly parallel to the ground. So if it is not perfectly parallel to the ground, then you need to hold the compass on either side with 2 hands and gently press on which side it is lowered. Okay, ఒక సైడ్ పైకి ఉండి ఒక సైడ్ కిందకు ఉంటే ఏం చేస్తామంటే రెండు చేతులతో పట్టుకొని అటొక చేయి ఇటొక చేయి పట్టుకొని ఎటుపైపు అయితే మనకి పైకి ఉందో కంపాస్ ని దానికి మెల్లగా కిందికి ఉంచుతాం. ఓకే, యూ షుడ్ డూ ఇట్ వెరీ జెంట్లీ. ఓకే, యూ షుడ్ నాట్ షోకేస్ ఆల్ యువర్ స్ట్రెంగ్త్ ఆన్ ద compass. So you should just hold the hands very gently and try to press the compass towards the one on which it is at a higher side when compared to the other side, till you achieve the leveling. That is, till you achieve, till you are able to see whether the compass is perfectly parallel or flat to the ground. Okay, so that process is called as leveling. Okay, and focusing. Focusing of the prism, you are seeing, you have seen some prism here, right? So this is a prism. So you are having a bottom here, a line, a attachment here. It is used to move up and down. The prism is moved up and down using this attachment. And the whole purpose of this prism is to ensure that you are able to see the values which are engraved in this compass on the circular ring are clearly visible to you. So the focusing of the prism is completely an aspect of the human who is working or who is using the prism, because I may have a different eyesight, you may have a different eyesight. I may be comfortable with some level of vision. I am able to read the values in the compass, but you may not be able to read the same focus. Yes, the focus is completely dependent on the vision of the observer. Suppose take the example of a person who is having a sight, and take a person who is not having any sight. What is the difference in those two people? Don't take it personally who are having sight, but what is the difference? Why you are using why you are using spectacles? A person who is having a poor sight, in order to clearly see what is written, right? In the same fashion here, it depends on vision to vision, vision of the observer to vision of the observer. A person who is not having any sight, a person who is not having any spectacles can look at the values very clearly even without focusing the prism. Just by raising the prism, he can see. But a person who is having sight or spectacles, definitely you need to adjust the prism so that there will be no strain on the eyes of the people. Okay, if you're not adjusted the prism, or if you're not focused the prism properly, and it causes strain to the person who is looking at the values, he can't continue work for more than half an hour or 1 hour. After that, his eyes will strain and he will move away. So the working should be comfortable. So in order to make it comfortable, this is one option provided by the instrument. Okay, you need to focus your prism till you are able to see the values comfortably without any strain to your eyes. Okay, so these three temporary adjustments are mandatory whenever you are shifting the instrument. Suppose in the earlier figure we have seen A, B, C, D, E. So at A, when you are establishing this compass instrument, all these three operations should be done. Once you have done the measurements, taken the measurements at A, when you are shifting the instrument to B, again these three operations should be performed at B also. Again, when you are shifting it to C, again these three. So whenever you are establishing a new station, or whenever you are moving from one station to other station, these three temporary operations of centering, leveling, and focusing are mandatory for compass surveying. Okay. So this is a pictorial view of the prismatic compass. You can go through what is in all textbooks, it's there. So coming to the next topic, what is a bearing? Before that, can any one of you tell me what is an angle? What is an angle? Are you there?
It is L-shaped, right, sir? Angle L-shaped.
Angle L-shaped?
L-shaped angle. Or angle which you measure.
Now tell me the basic definition of an angle.
Which is formed by two rays.
Is formed by two rays.
So the inclination formed by two points or something.
So it is nothing but the variation in the direction of two lines sharing a common point. Okay, the variation in the direction of two lines sharing a common point. This is, assume that this is one point. Okay, this is one line and this is another line. This is the direction of one line. This is the direction of other line, but these two lines are sharing a common point. So the angle, what we can say, the change in the values of this direction of these two lines is called as an angle. Okay, but though we are referring angles in compass surveying, but we are not going to measure the angles. We are going to measure the bearings. Okay, so please keep this in mind. Using a compass surveying, you are not going to measure what are the angles. You are going to measure what are the bearings. After you have measured the bearings, you are going to calculate what are the angles. Okay. So a bearing is the line. Suppose take this example, a line AB is there. Okay. A is an object and B is an object, and this is the one direction line AB. Okay. So the bearing of line AB is nothing but what is the value? Okay. What is the angular value of this line AB with respect to north meridian? I hope you all know what is north meridian. What is north meridian? చదివారా లేదా స్కూల్లో ఇప్పుడు ఆన్సర్ చెప్పకపోయినా పర్లేదు కానీ whether you are aware of what is true north, what is true west, magnetic meridian, magnetic north, true meridian,
Yes,
true
sir.
north. Okay, just if you don't remember or if you can't recall, just go back to those basics once again. Okay, so in surveying, in compass surveying, what we are going to do, we are going to measure what is the bearing of the given survey line with respect to magnetic north. There are two norths. One is true north and another is magnetic north. True north is established by making the reference to the stars in the sky. So the advantage of making a true north or establishing a true north is it doesn't change till the earth is existing. The position of MVSR Engineering College, if I want to establish what is the true north of MVSR Engineering College, I'm going to fix what is the true north of at MVSR Engineering College with respect to some celestial body, with respect to some star in the sky. The position of MVSR Engineering College doesn't change. The position of star in the sky doesn't change. So you can take the, once the true north is established, you can take that as a perfect one. But a magnetic north changes from time to time. If today, if the magnetic north of MVSR Engineering College is north 43 degrees east, if you go back to 5 years, or if you go front by 5 years, definitely the value will not be north 43 degrees east. It might be 41 degrees, it might be 47 degrees. Because the magnetic north changes depending on various factors, depending on the rotation of the earth, depending on the temperatures, okay, depending on some storms, magnetic storms which might occur in the earth's surface, above the earth's surface. All this will have an impact on the magnetic north. So magnetic north is susceptible to change from time to time and from place to place. But a true north is not going to change at all. Once you fix a true north, it is going to be forever. Okay, but all our readings by default are with respect to the magnetic north. So that is why we call all these bearings as magnetic bearings, not the true bearings. Okay. So now if you can see here, there is a north point, end point which you are able to see, and there is a line AB. Okay. So what I am doing, I am going to establish my compass instrument at A, and I am going to rotate my compass till I am able to see the object at B through the sight vane. Through the object vane. Okay. So once I am able to sight this object at B, I will read out how many graduations are there from this end to this line. Okay. How many graduations are there in the compass instrument from this end to this object. So I'll count all those graduations and tell that the angle between or the bearing of line AB with respect to magnetic north is 30 degrees or 33 degrees or 36 degrees, whatever may be the angle. Okay. Then if I want a second line, assume that there is another point here. Okay, let us assume that this is point C. And we have another line. Let this be point D. Okay. So I am establishing now point A in the instrument, in the ground. I am doing all my temporary adjustments, centering, leveling, and focusing. Then I am going to rotate my compass till I am able to find the object B through the instrument. Once I sight this object at B, then I am going to measure what is the, how many graduations are there between the magnetic north and the given object, and I am going to report it as the bearing of the line AB. Once this is done, what I'll do, I'll rotate my compass till I am going to sight the object C in the ground. So my compass and tipputu a prism line chustu untaru till the object C is visible through the slit or through the opening in the compass. Once you sight that C object in the field, again you will measure what is the distance, what is the angular graduations that are there from north to this point. Okay. So you are going to measure from here to here. How many graduations are there? So this is going to be the bearing of AC with respect to north. So the magnetic bearing of AC will be some value. Again, I'll rotate from A to D and I'll find out what is the bearing. So once you get these two bearings, now what is the angle? What is the angle between BAC, or what is the angle BAC now? It's the difference of the bearing of AC minus bearing of AB. Do you all accept with it? From here to here I have measured. Okay. This is my north. This is B. This is C. This is A. Okay. So now what is bearing here? The bearing is nothing but with respect to north. Okay. The bearing of AB is what is the angular distance from north to line AB. The bearing of AC is from here to here. Okay. From here to here, what is the angle, or what is the angular value, or what is the how many graduations are there with respect to north. So from this diagram, what is the angle BAC now? As per the definition of angle, it is a deviation in the directions of two survey lines with respect to a common point. Here AB and AC are two survey lines and A is the common point. So the difference between these two will give you what is the angle of BAC or what is the angle of A, right? So that is the difference between bearing and angle. So bearings are definitely and mandatorily measured with respect to either true north or true magnetic north. And from the bearings of two different lines, you are going to measure what is the angle between them. Okay. This is very, very important. If you have any confusion, please let me know. The bearings are always measured with respect to magnetic north or true north, and it is defined as the, and say in simple words, it is defined as an angle between the given survey line with respect to magnetic north or true north. Okay. But an angle is the difference between two survey lines sharing a common point. Okay. And so there are two ways of designating these bearings. Okay. One is here also you can clearly is visible. This is the true north and this is the magnetic north. Okay. The angle measured with respect to true north is called as the true bearing. The angle measured with respect to the magnetic north is called as the magnetic bearing. And the difference between the true north and magnetic north is called as the magnetic declination. Okay. So there are two methods of designating these bearings. One is the whole circle bearing system and other is the quadrantal bearing system. Sometimes we call quadrantal bearing system as the adjacent bearing also. In the whole circle bearing, what happens is the compass will be having from 0 to 360 degrees. Whereas in the quadrantal bearing, you'll be having in the form of 4 quadrants. North quadrant, first quadrant is 0 to 90 degrees, second quadrant is 90 to 180, third is 180 to 270, and fourth is 270 to 360 degrees. Okay. So we will see the first one, whole circle bearing system. See here you can see from 0 to 360 degrees, you will be having the designation on the compass. Okay. So you can have any value from 0 to 360. 1, 2, 3, 4, 5, 6 like that up to 359. 0 and 360 again coincide. So how do we measure the bearing, whole circle bearing of a given line? See in the first figure, you are having a north-south line and you are having an east-west line. Okay. This represents the quadrant. I hope you are all aware of it. What is first quadrant in this? This is first quadrant. This is first. This is second. This is third, and this is fourth quadrant. I hope you are all aware of these quadrants, right? Sir,
Yes,
no.
sir.
Yes, sir.
So in the first, okay. So let us first go to the whole circle bearing. So here there are 4 lines. OA is one survey line, OB is another survey line, OC is another survey line, OD is another survey line. We are having 4 survey lines in the given figure. Now I want to determine what is the whole circle bearing of OA, what is the whole circle bearing of OB, OC and OD. So as per the definition of the bearing, what is it? It is that as per the definition of the bearing, I need to measure what is the angle of this line OA or OB or OC or OD with respect to the north, magnetic north or the true north. So if you take this line OA, what is the angle of this from N? This is the angle, right? This is the angle of line OA with respect to ON, theta. Okay. And what is the angle of OB? From here to here. From ON, what is the angle of OB? So this is the value, right? Then OC, from here to here. OD, from here to here. This big one. So what I am doing? The line, the direction of the line, I am going to measure it only with respect to north. Okay. So if you are measuring only with respect to the north, then it is called as a whole circle bearing system, and the values ranges from 0 to 360 degrees. Any value between 0 to 360 degrees. But it can't be more than 360 and it can't be less than 0. Okay. But when you come to the quadrantal bearing system, what we do is we measure the direction of the given survey line in the quadrant itself. Now this quadrant is called as northeast quadrant, right? One side it is north, other side it is east, and it's also called as first quadrant. So what will be the value at north? 0 degrees, obviously. What will be the value of east? See the figure and tell me. What is the value of east?
90 degrees. 90.
90 degrees. What is the value of S?
180
With respect to north?
180. 180.
What is the value of west with respect to north?
270 degrees.
Okay. So the first
270.
quadrant, the range is 0 to 90. Second quadrant, the range is 90 to 180. Here it is 90, here it is 180. Third quadrant, it is 180 to 270. This is 270. And the fourth one is 270 to 360. So any value between in northwest will be from 270 to 360. Any value between northeast will be 0 to 90. And between east and south, it will be 190 to 180 and 180 to 270. So this thing you please keep in mind. Okay. Or remember the quadrant diagram. That is sufficient. You need not by heart all this. Remember a quadrant diagram which you are already learning from your school days. Okay. Just draw two perpendicular lines, northeast, westward. You know what are the directions. Okay. 0, 90, 180, 270. That solves most of your problems. Okay. So this is how we are going to measure. So I'll show you some problem, then you'll be able to understand very clearly. Okay. But in the quadrantal bearing or the reduced bearing system, what we do is here in the whole circle bearing, the whole circle bearing of OA is called as theta. But when it comes to the representation in quadrantal or reduced bearing, the bearing of OA will be written as north theta east. That is, you are going to designate in which quadrant the survey line is there. So it is represented as north theta east. When you come to the second line OB, okay, it is there in the second quadrant, east, southeast. So the direction of the line OB is written as south alpha east. So you are going to measure from south, not from the east. Okay, in the first quadrant it is north theta east. In the second quadrant you are going to measure what is the direction of the line AB from south. So south alpha east. And when you come to the third quadrant, south alpha west. And when you come to the fourth quadrant, it is north alpha west. So what did you observe from this? In a quadrantal bearing representation, the starting letter should definitely be either north or south. And you'll be having an angle in between, and the ending letter will be either east or west. So if it is in the first quadrant, it is north alpha east. If it is the second quadrant, it is south alpha east. If it is the third quadrant, south alpha west. If it is the fourth quadrant, north alpha west. So this notation, you please keep it in mind. Okay. So how to convert from one system to other system? Till 12:10 is right, class. Okay. So this is the table which is used to convert the angle from one system to other system. So suppose if a whole circle bearing of 45 degrees is given, okay, that is it lies between 0 to 90 degrees. So the quadrantal bearing is north east. So north 45 degrees east will be your quadrantal bearing. So if the whole circle bearing is 90 to 180, then the reduced bearing is 180 minus WCB. Then the quadrant is southeast, 180 to 270, WCB minus 180 southwest, 270 to 360, 360 minus WCB northwest. Okay. Similarly, if a RB is given, you can even convert it to whole circle bearing. We'll see some example, then only you'll be able to understand very clearly. Convert the whole circle bearing WCB into reduced bearing 49 degrees, 240 degrees, 133 degrees, 335 degrees. Okay. So whole circle bearing of 49 degrees is given. Okay. So the angle between north and this line is 49 degrees as per whole circle bearing. So what is its corresponding reduced bearing? So in which quadrant you are getting this value? This line is in the first quadrant, right? Yes or no? I'm telling you, this is very, very important. If you don't understand this, you will not be able to solve any problem of compass surveying. So don't feel shy. If you're not able to understand, tell me, I'll repeat it. Okay. So this line is in the first quadrant, northeast quadrant. As per quadrantal bearing notation, what should be the value now? North 49 degrees east. Whole circle bearing is 49. So as per quadrantal bearing, it will be north 49 degrees east. Okay. Now let's move to the second one. Take an example of 240. Where does 240 come? In which quadrant you will get 240?
Third quadrant.
Third quadrant. You can see here in the figure, this is the line which is in the third quadrant at an angle of 240 degrees with respect to north. This bigger line, this one. Okay. But from north to south, what is the angle? 180, right?
180.
Okay. So in order to determine the quadrantal bearing of this line, which is in the third quadrant, as per notation, it should be southwest because it is lying in the southwest quadrant. But when you are converting a whole circle bearing into quadrantal bearing, you are definitely required to measure the angle of that line only with respect to north-south line. So from here to here it is 240. From here to here it is 180. So what is the difference between these two now? 240 minus 180?
60.
So 60 is the value. So the quadrantal bearing of this whole circle bearing of 240 is south 60 degrees west. Okay. Ardhamainda? I've been given a value of whole circle bearing from 240 from the north. The line is at an angle of 240 degrees with respect to north. Okay. But as per quadrantal bearing representation, I need to represent this value in between southwest only. And southwest quadrant on the outer line. Is the picture audible, clear?
Yes, sir.
Okay. Because this line is in the third quadrant, as per quadrantal bearing notation, I need to represent in between southwest only. So what is the distance between this south line and this line? What is the angle between the south line and this angle? This line is, this whole angle is 240, but from north to south it is 180. So I am subtracting 240 minus 180. I am getting 60 as the value. So the reduced bearing of this line is south 60 degrees west. Okay?
Excuse me, sir.
Yeah, tell me.
Sir, can't we write north 240 west?
It is in the third quadrant, right?
Yes, sir. Without writing south 60 west, can we write north 240 west?
How north 240 you will get? No, the representation of quadrantal system is that quadrantal bearing. What do you mean by quadrant? So the value should be in between a quadrant. Either it can be northeast or southeast or southwest or northwest, but it can't be northwest or southwest, like north-south. Okay, quadrant and చూపిస్తున్నాం కదా మనము ఇక్కడ. The name itself shows quadrantal. Okay, so the line which
Yes, sir.
in which quadrant it falls, those two endpoints should be represented. Okay, northwest
Okay,
అంటే మీకు ఈ quadrant లో రావాలి.
Hmm.
Okay, and the whenever you are giving the representation in a quadrantal bearing, the starting letter should definitely be north or south. It can't be east or west. Okay, from north, and how much is the angle? From south, how much is the angle we are going to measure in either clockwise direction or anti-clockwise direction?
Okay, sir.
So can you please repeat how to read the angle? So like south 60 going west, sir.
Yes. Suppose if there is a line in first quadrant, it is going to be north angle east. If a line is in the second quadrant, it is going to be south angle east. If it is the third quadrant, south angle west. If it is the fourth quadrant, north angle west. We'll see another problem here, the fourth one. Fourth quadrant. Here the whole circle bearing of the given line is 335 degrees. Okay, so from north, the angle is 335 degrees. So which quadrant it comes? It comes in the fourth quadrant, right? Because the fourth quadrant range is 270 to 360. Okay, this is the line at an angle of 335 with respect to north in this clockwise direction. But when it comes to quadrantal bearing, what we need to do? We need to measure it from north. Okay, so what is the distance of this line OA in this fourth quadrant from north? Is 360 minus 335 will give you 225 degrees. So we'll represent it as north 25 degrees west. Why we are taking only north and south is by default any measurement on the ground is with respect to north direction. All surveys are done with respect to north direction only. That is why north is very important for us. You take any housing plan also, they'll show what is the north direction in that plan. Okay. So it's very easy. Just if you need some time, some type of practice on this. Okay. I suggest don't remember these equations what I have told you here. These equations you please don't remember. Remember how to draw the diagram. Okay. Draw the diagram of a quadrantal bearing. So draw the diagram of the quadrant northeast, west, south. And remember, northeast varies from 0 to 19, southeast varies from 90 to 270, 270 to 180 to 270, and 270 to 360. ఇవైతే జనరల్ గా స్కూల్ పిల్లలకు కూడా గుర్తుంటాయి. మీరు ఫిగర్ చూస్తే మీరు చెప్పగలగాలి. రైట్ ఆర్ రాంగ్? ఇఫ్ యూ హావ్ 4 డైరెక్షన్స్ లైక్ దిస్, ఈ యాంగిల్ ఎంత, ఈ యాంగిల్ ఎంత అంటే తెలుస్తుంది కదా అందరికి. సో బేస్డ్ ఆన్ దట్ యూ డ్రా యువర్ డయాగ్రామ్ వాట్ ఎవర్ వాల్యూ ఇస్ గివెన్. Then find out in which quadrant it is going to come. Then subtract that value with respect to north and south, you'll get the quadrantal bearing. Okay. The vice versa of this is the whole circle bearing. Okay. I'll share this PPT today to you. Okay. Please go through this PPT and try to solve some problems.
Okay.
ఎందుకంటే ఇది చెప్పినా కానీ అంత ఈజీగా బుర్రకెక్కదమ్మా. Until and unless you don't practice, and ఇక్కడ మీరు కష్టపడాల్సింది కూడా ఏం లేదు. Just you need to identify what is the angle. అంతే. Okay. I'll post this in the Google Classroom. You please try to practice it. And next class we will see. If at all you have any doubts, we'll see. And I would like to take a class on Saturday. Are you okay with that? ఎవరు సపోర్ట్ చేయట్లేదు?
Yes, sir.
Can I take a class on Saturday?
Yes, sir.
Okay, sir.
Yes, sir.
Okay, sir.
No, sir. No, sir.
I'll share this today to you. You please solve the problems. We'll discuss further regarding this in the next class. Why I'm telling is, if you don't understand this, you can't solve a single problem in the next topics. Okay? So you practice and come back on Saturday. I will have a class on Saturday and I'll clear your doubts. Okay? Please tell me your attendance. Are you getting SMSs? Attendance SMS వస్తున్నాయా?
No, sir.
No, sir.
No, sir.
Sir, yesterday we attended that the class geographical information system regarding satellites and everything.
Hmm.
I could attend the normal session from 4 o'clock to 5 o'clock, the class, sir, but I couldn't attend the interactive sessions. I didn't find it anywhere on the website.
No, when you log in, generally you'll be getting the live chat box rate, right? You're not getting that?
Chat box, sir.
Like if
Okay,
you have
sir.
any doubts, you need to post it in the chat box, and at the end of the session, they'll get back to you.
Okay, sir.
Okay.
Yes, sir.
And request you all to attend. You need to maintain 70% attendance in that program. Then only you will be eligible to write an exam. And the exam will be for 30 minutes, objective type. 30 minutes, and you'll be having around 30 questions, and you need to get 20 marks in order to clear the exam. Then only you'll be getting the certificate. Okay. So clearing an exam of 30 minutes is not that difficult for you people, I guess. But attend the sessions. If you want the offline lectures, I'll give you the offline lectures also.
Okay, sir.
But once you attend, if you miss something, you please inform me. I'll try to share you the offline lectures of those people. Okay?
Yes, sir.
And
Thank you, sir.
minimum, in order to get the attendance, you need to log in at least for 30 minutes. Please keep that in mind. In 30 minutes login అయితేనే మీకు అటెండెన్స్ మార్క్ అవుతుంది. అటెండెన్స్ మార్క్ చేసింది ఏం కాదు, ఆటోమేటిక్ గా వాళ్ళే తీసుకుంటారు based on your login details. Okay? Ensure that if you are logging in, minimum 30 minutes you need to log in. Then you will get the eligibility to write the exam. Okay? Exam is free of cost. You need not pay anything. Course is also free of cost. You need not pay anything. If you want, I'll share you the certificate, how it will be, okay, to any one of you. Then you can see you'll be getting a certificate on the name of ISRO as well as Indian Institute of Remote Sensing. I'll share you one photo, wait, near WhatsApp group. Tell me, 1 second. To be right.
Yes, sir.
So I have shared a certificate. You'll be getting a certificate like that on the name of Indian Institute of Remote Sensing and Indian Space Research Organization. So which will be definitely valuable for you in your future also. Okay. And if you have any doubts regarding the topics which they are covering in GIS, either you can contact me or Padmaja Madam. Okay. So please tell me your roll numbers. 45 people are available today. Oh God. 18117. 62.
Yes, sir.
63.
Present, sir.
64.
Present, sir.
65.
Present, sir.
66.
Present, sir.
68.
Present, sir.
69.
Yes, sir.
70.
Yes, sir.
71.
Yes, sir.
74.
Yes, sir.
75.
Yes, sir.
76.
Present, sir.
77.
Present, sir.
29.
Present, sir.
80.
Present, sir.
81.
Present, sir.
82.
Present, sir.
83. 84.
Present, sir.
85.
Present, sir.
86.
Present, sir.
87.
Present, sir.
88.
Present, sir.
89.
Present, sir.
90.
Present, sir.
94.
Present, sir.
95.
Present, sir.
98.
Present, sir.
99.
Present, sir.
101. 102.
Present, sir.
104.
Yes, sir.
105.
Present, sir.
106.
Present, sir.
107,
Yes, sir.
110,
Present, sir.
111,
Present, sir.
112,
Present, sir.
113,
Present, sir.
115. Nidra 115, 118.
Present, sir. 115 present, sir.
Okay, 118,
Sir, present, sir.
119,
Sir, present, sir.
120.
Present, sir.
Who is the class here?
Sir, 118, me and Saad, sir.
Okay. Actually, some 18 students have joined through lateral entry. Okay. And I'll share their numbers to you people, both of you, boys here and girls here. Ensure that they're also joined in this WhatsApp group and they also continue with the classes. Okay. Join, huh?
Yeah, yes, sir. Yes, sir.
Okay. I'll share their numbers to you people. Okay. If at all any material is required for them, please do help them.
Yes, sir.
Okay. Right. Bye for the day.